Here we introduce AntTS, a toolkit for time series forecasting in industrial scenarios. Time series forecasting is fundamental to business intelligence. In industrial scenarios, the time series of interest are mostly macroscopic time series that are aggregated from microscopic time series. More importantly, the macroscopic time series are also intervened by certain treatments on microscopic individuals. It is necessary to study the impact of the treatment on microscopic individuals over time to help the forecasting of. Recently proposed toolkits are mainly focused on the natural time series forecasting, which build models on the macroscopic time series itself without considering microscopic data, and ignore the time series forecasting under the treatment. As a result, the functions of existing toolkits cannot fully meet the actual needs of the time series forecasting in the industry. Therefore, we present AntTS, a time series toolkit that refines 3 decoupled modules: clustering module, natural forecasting module, and effect module, which is the core of our toolkit. Each of these modules is able to handle their corresponding tasks individually, and most importantly, their combinations can accomplish various non-trivial time series forecasting tasks in the industry. We first introduce the clustering module, which has 3 components: data, mixsec, and inference. The 3 are linked by arrows. We can start the operation of the whole clustering module by clicking the data component at the top and right-clicking and selecting Execute from here. Now, it's running. We omit the intermediate run time. When we click the component, the corresponding configuration will appear on the right, which can be filled in as needed. Taking inference component, for example, we click to select the features, model paths, and other configurations required for prediction. Then, we finish the clustering part. Next, we can intuitively feel the clustering part by showing the sales trend of each group after clustering. After some processing of the results, we complete the drawing through the clustering draw component. After running, we can see that the sales patterns and magnitude of 10 groups are basically the same within the group, and have their own characteristics among groups. Next, let's enter the natural forecasting part. In the clustering module, we get the K-group time series. We zoom out the clustering part to simplify the space. Firstly, through data processing component, we can aggregate and pre-process K-groups from clustering part. We can carry out time series natural forecasting training through causal transformer component from forecasting module. Then inference component performs inference to forecast time series from the test sample and trained model. Finally, we sum all to one time series as the natural forecasting result of target time series. Now, we finish the natural forecasting part. In order to intuitively understand the effect of microscopic time series clustering on natural forecasting, the same algorithm is used to directly forecasting the total retail sales, and the forecasting results of the two are displayed by drawing. After running, it can be seen that the prediction accuracy of macroscopic time series has been improved after clustering. So far, we have completed the clustering part and the natural forecasting part, and also zoom out them first. The effect part includes 3 components such as data pre-processing, autosex effect, and inference. According to the K-groups obtained by clustering part, we pre-process samples by data pre-processing for autosex effect component to estimate the impact of a treatment. After inference, the forecasting of clustered time series under treatments can be calculated by adding the above estimation and the natural forecasting obtained by natural forecasting part. Finally, the forecasting of macroscopic time series under treatments is the sum of above clustered time series forecasting. Now, we directly display the results of each group's effect estimation. Our toolkit has also been applied in industrial scenarios. Therefore, the results of a /B test in the application are also shown here. One bucket does not be imposed by any treatment, and the other homogeneous random bucket. The blue line is the real effect value, the yellow is estimated by experts according to history and expert experience, and the green is the estimated value of our model. It can be seen that the estimated value of the model is closer to the real value in terms of waveform and value.